Assalamualaikum and good morning to our respected judges, our audience and also everyone. So today, my group will be presenting about our project that called KawanBorong AI, an AI-powered predictive smart procurement and supply chain ecosystem. So, our project focuses on helping F&B, vendor businesses improve the way they purchase, manage and monitor their ingredients. Now, before explaining our solution, let's first look at the problem faced by restaurant operators. The first problem is food waste. Many restaurant owners rely on intuition when purchasing ingredients. As a result, they may purchase more perishable ingredients than necessary, causing unused food to spoil. The second problem is time cost. Owners may spend excessive time visiting physical wholesale markets and contacting suppliers manually. There is poor resource utilization. Unpredictable orders can cause stockouts during peak hours and overstocking during periods of low demand. And finally, manual stock counting and supplier follow-up increase labor requirements and human error. So, to address these problems, we propose KawanBorong AI. Our system uses AI to predict ingredients requirements by analyzing daily sale trends, inventory, weather, and local events. The system also synchronizes restaurant demand directly with suppliers, allowing suppliers to prepare ingredients more efficiently. In addition, our automated AI assistant reduces manual administrative work, while market intelligence analyzes factors such as price changes, seasonal demand, and supply availability. So, our solution is aligned with SDG 2, Zero Hunger, SDG 8, Decent Road and Economic Growth, SDG 9, Industry Innovation and Infrastructure, and lastly, SDG 12, Responsible Consumption and Production. Now, let's talk about our target audience. Our main target audience consists of three main groups. First, restaurants and food vendors who want to automate ingredient prediction and reduce food waste. Second, wholesalers and suppliers who need better demand forecast and smoother fulfillment. Finally, logistic partners who can use synchronized procurement data to optimize delivery timing and routes.
The system works through 8 main steps. First, restaurant owner log into the platform and access their personal procurement dashboard. Second, the system track ingredient inventory by batch, including the stock quantity, stock age, and usage rate. Third, the AI analyze the remaining inventory together with menu sales pattern, weather, and event information. This allows the system to predict future ingredient requirement and identify potential shortage or waste. Fourth, the system automatically generates an optimized procurement recommendation. The restaurant owner can review, adjust and approve the recommendation. 5. The approved order is sent directly into the supplier dashboard, allowing supplier to track the order life cycle. 6. The virtual time simulation allows user to model future demand and test different procurement strategy. And 7. Finally, the system provide waste and financial analytics, while surplus or nearly ingredient can be recorded through the food donation impact tracker. Phase 3 stage establish the foundation of the system. The restaurant access the platform inventory is tracked in real time and the AI analyzes the available data to predict future ingredient requirements. Next, the system recommends the required order. After approval, the order is connected to the supplier, while the virtual time simulation allows users to test different future demand situations. The final stage focuses on performance and sustainability. The system measures waste and financial impact, while surplus food can be recorded through the food donation impact tracker. To better understand the system, let's take a look at a practical scenario. Imagine a restaurant finishing its operation at 10 p.m. The manager logs into KawanBorong AI. The system checks the current batch inventory and analyzes tomorrow's expected Friday lunch demand, local weather, and historical sales. Based on this information, the AI generates a specific recommendation. For example, 18 kg of chicken, 5 kg of onions, and 2 kg of ginger. The system also identifies that some remaining onion will expire within the 24 hours and use simulation to reduce the risk of future stock out. The restaurant owner review and approve the recommendation with one click. The order is synchronized with the supplier dashboard. The supplier can prepare dry goods earlier while scheduling fresh chicken closer to the morning delivery. As a result, the restaurant can receive the required quantities while reducing unnecessary purchasing and avoiding peak hour stockouts. Behind the application is a layer architecture connecting the front-end, back-end, database, AI service, and external API. This allows the different components to communicate and support the complete procurement workflow. Our technology stack, the front-end uses HTML, THMyLif, CSS, and JavaScript. The back-end is developed using Spring Boot 4.1 and Java 21. For database management, we use Google Firebase Firestore, which support our batch-based inventory tracking. For AI functionality, we use OpenAI GPT-4.0 dashboard and history summarize. We'll also integrate the MyCal Malaysia calendar API for Malaysia holiday information, while session-based authentication manage user access.
Kawan Module AI consists of several core modules. The dashboard provides KPIs and AI performance reviews. The smart ordering modules generate AI recommendations, while the inventory modules manage cooking, discarding, and donating inventory. We also have waste and financial analytics, donation tracking, history, and a simulation engine. Together, these modules create an integrated procurement management system. One of the most important features is our smart ordering mechanism. The recommendation considers several factors. First, weather condition can influence expected demand. Second, public holidays are detected through MyCal API key and can increase the expected demand also. Third, previous waste records are considered, so the system can adjust the recommended quantity based on the past waste. Most importantly, every recommendation includes a confidence percentage and a reason text. This makes the AI recommendation more explainable instead of simply just give a user a number without context. For testing, we first verified the authentication and inventory functions. The business name login was successfully tested, and the batch-based inventory tracking displayed real-time stock information as expected. For the AI demand analytic, we tested different conditions including clear skies and heavy rains. The AI successfully produced different suggestions based on the provided weather data, showing that the weather can influence the procurement recommendation. We then tested the proactive order recommendation, supplier submission, and virtual time simulation. The order recommendation successfully assisted users in making procurement decisions. The order could also be submitted to the supplier, while the simulation feature allowed users to fast forward time and model their future demand. For the final two features, the waste and the financial dashboard successfully recorded inventory losses and monitor waste levels. The food donation feature also successfully recorded surplus food and its sustainability impact through the donation tracking process.
Yeah, finally, let's look at the impact and feasibility of KawanBorong AI. Our market research identifies a significant opportunity within the Malaysia F&B industry, particularly among SME operators. The project also highlights a technology gap where many F&B SMEs still rely on manual and reactive procurement methods. Based on our projected impact, KawanBorong AI aims for 30% food waste reduction, 15% ingredient cost savings, and 70% time efficiency improvement. The system also creates a closed-loop supply chain by connecting restaurants, suppliers, and food donation channels. Therefore, the project is not only focused on improving restaurant operation, but also aims to reduce food waste and create a more efficient and sustainable food supply chain. So this is our references. Now let's move to our product demonstration.
Okay, now we go to the demo. Let's say I make a new cafe named Aslam Cafe. So we enter the dashboard, you see nothing is here yet because we haven't ordered anything. So we go to smart ordering. We order a few things like chicken at 10 kgs. We go to tomatoes at 5 kgs and milk for 7 liters. See, everything goes into one cart. So we can confirm order to push it into inventories. So since this is a simulation, we can go straight to the inventory. Inventory, you can see all the things that we have ordered. See, we can cook some of them, and then we can cook all of them. We have the option to go fast forward for 24 hours just to see more features. Again, we can cook some of them, but if there is only one day to expiry, you can see there's another option to donate. So this is very aligning for one of our SDG to let not people be hungry. So we can cook some of them, we can donate and also discard, and we can cook all of this. So we can go straight to the waste section. What have we wasted? We have wasted chicken breast, and the value is at 113 according to Malaysian market. And we have also the AI overview. This one is powered by OpenAI. And we can go to the donation. You can see that we have successfully donated milk to Food Bank Malaysia, and there is an AI overview here. We can go to history and it shows what we have done for the day. You see, this is all the things that we have cooked, all the things we have discarded and also donated. We have been given the AI summary for the day. So this thing is powered by Firebase for the database and OpenAI for the AI. For now, we have no authentication, but we can easily add them using Google authentication or phone number authentication. And also we have a few UCRIX data sets for us to see. As you can see, we have given several inventory batches, and they have given us a good AI performance review. You see, everything is powered by AI.